Did you know that traditional irrigation methods waste up to 50% of water? Smart irrigation can reduce that number to almost zero. Assalamualaikum and good day. My name is Jadal bin Mustafa. My team and I will present the technical report that we had completed. Our team consists of Mr. Abdul Jabbar Mohsin bin Musa, Muhammad Adrian Shah bin Abu Samah, and Mr. Muhammad Ikhwan bin Abdullah. Before I start, I would like to take this opportunity representing my team to express our gratitude to Madam Mai for the unwavering support and guidance throughout this project. The purpose of this presentation is to provide a detailed analysis of smart irrigation system. This will cover 5 main chapters: project introduction, literature review, methodology, result analysis, and lastly, conclusion and recommendations. This report intended for WEB20302 Professional English 2, which is part of the UniKL BMI assessment and requirements. I will start with the project background. Smart irrigation system is an Internet of Things IoT based project. It uses Blink apps for monitoring, ESP8266 Wi-Fi module as a controller, soil moisture sensor, and solenoid valve as an actuator. When the soil is dry, solenoid valve will open automatically to allow the water flowing for irrigation process. When the soil is wet, the solenoid valve will turn off and stop the irrigation process. It can be adjusted based on humidity level required on the soil where the crop is planted. The reason we choose this project is we found out farmers face challenge of water scarcity due to less rainfall. They sometimes have to irrigate the field during odd hours due to variations in supply. There are also changes of overwatering and underwatering in a few circumstances due to human error. The objective of the smart irrigation project is to develop an automated irrigation system that can optimize water usage in agriculture. The system will use soil moisture sensor, weather data to determine the optimal amount of water required for crops. The system will also be able to detect the moisture content of the soil and sprinkle water depending on it. This entire information will be sent to the user's mobile phone. The significance of this project is to optimize water usage in agriculture by using artificial intelligence and data monitoring. This system can help farmers conserve resources, increase efficiency, and reduce costs. The system can determine the optimal amount of water required for crops, thereby reducing water wastage and increase crop yield. It also helps farmers avoid overwatering or underwatering the crops, which can lead to crop failure and financial losses. Furthermore, the system automates the irrigation process and provides real-time data on soil moisture level and water usage. This helps farmers save time and effort while ensuring that their crops receive the right amount of water at the right time. The limitation of this project is that it requires an internet connection to transfer data to the cloud server through Wi-Fi. Although the device will still function, it cannot be monitored through the Blink apps. I will stop here and I will let Mr. Jabbar to take over for the next slide. Thank you.
Thank you, Mr. Jadal. Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Jabbar Mohsin. Today I would like to present about the general review. Do you know what is the irrigation? Irrigation, it can be defined as a method to delivering water to the plants. From the previous research, most farmers are using manual and time-based method. due to the financial constraint to afford expensive automatic irrigation devices. So both methods are inefficient that will cause overwatering and underwatering, which can lead to the crop failure and financial losses. What is the advantages of this project? The main advantage of the smart irrigation system is the lawn and the plant can be well maintained with the accurate amount of water required. The implementation of the irrigation system will help minimize the usage of water, and then the wheat will grow, increasing the growth rate of lawns, plants and the crops. So in this project, ESP8266 is used, which is the main controller of the whole process. It has a Wi-Fi enabled function which can be integrated using Blink apps on the smartphone. Most of the current research projects use Arduino Uno at Mega 328, which has similar function and application, but impractical due to the cost is a bit pricey compared to the ESP8266. Some other researchers are using Raspberry Pi and the GSM network. There are different type of method for irrigating farm field for different type crop field. Basically, a farmer use this four method: surface system, sprinkler system, drip system and subsurface system. A smart irrigation system is a new technology to the irrigating farm field automatically, which is suitable for this type of method. So I will stop here. I will let Mr. Adrian to take over for the next slide. Thank you very much.
Thank you, Mr. Jabbar. Hello and greetings to Madam Mai and everyone. My name is Muhammad Adrian Shah bin Abu Sama, and I will present the methodology for our project. In this chapter, I will share the theoretical and experimental research related to our project. This involves several technical terms, and I will explain as best as I can to ensure our non-technical audience will understand the subjects I am about to share. I will start the presentation with the question: why the methodology is considered a key factor in resulting in success of one project? The answer is the methodology will drive the project member to come out with the fundamentals of the design by developing the block diagram, schematic diagram, and flowchart, which will act as guidance to ensure the correct procedure or method will always be in place. Moreover, it is also to get all the crucial information related to the hardware and software which will be used for the whole process of designing the project prototype. Next, let us look at the flowchart. Do you know it is also known as a process flow diagram or process map? It is a graphical representation of a process or algorithm. It shows the step in a sequence and the decision points along the way. For our project, the flowchart was used to document, analyze, and improve processes implemented in the project. Now, I will share the hardware used in our project. The first one is called ESP8266. It is used to control input and output based on the code program. From a layman's perspective, this hardware acts like a brain to the system. The second hardware is called moisture sensor. It is used to measure the moisture and humidity of soil. The third hardware is called solenoid valve. It is an electromechanical device to control the flow of fluids, for instance, the water flow. From a layman's perspective, this hardware acts like an entrance or gate to allow or stop something from going in or out. The fourth and last hardware is called relay. It is used to control the flow of electricity, which is larger than its nominal supply. It is controlling the electric supply of the solenoid valve. The function is similar to an entrance or gate, which is in this case is used to control the flow of electricity to the solenoid valve. Alright, let us look at the software that was used for this project. Now, this will be the interesting part, as some of the software that I will mention later, you might never heard about it before. The first software is called Arduino IDE. It is used to write and upload the code to Arduino Compatibility Microcontroller Printed Circuit Board, the short form PCB. we are using this software to insert the command, which is the program code, into the microcontroller PCB. The second software is called Blink. It is used for remote monitoring and control of connected devices to cloud servers. It is the apps that can be downloaded to your smartphone and control the associated device remotely. The third software is called Freezing. It is used to develop a schematic diagram and PCB prototype. Just imagine a painting artist painting something on the paper. The painting artist is the engineer. The desired painting is the schematic diagram, and the paper is the freezing software. So basically, the engineer is painting the schematic diagram using this particular software. The fourth and last software is called Tinkercad. It is used to simulate and visualize the project prototype using the code created by Arduino IDE software. This particular software is to show the project prototype and its operation on the laptop or computer screen without assembling the device prototype beforehand. Do you still remember the Blink apps that I mentioned earlier? The step after the prototype was successfully assembled is to synchronize the device with this app. This is the process of how to synchronize the controller, which is called ESP8266, with the Blink apps. This synchronization is important for the monitoring process of the smart irrigation system. Once the process is completed, it will show the components registered in the monitoring system. Now, the smart irrigation system can be controlled remotely by using a smartphone. Lastly, to track the project's progress, the Gantt chart has been used to portray the project schedule. The following Gantt chart shows the overall process of completing the design project. This project takes 17 weeks from the beginning to the completion. I will stop here and will let Mr. Ikwan to take over for the next slide. Thank you.
Thanks to Mr. Adrian and all members. Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Ikwan bin Abdullah. I would like to continue this presentation, result and analysis. Firstly, in this chapter, project phototype is used, which contains the detail of the project result and the real pictures of the complete project. It is describing the real function of the project. Besides, it also determines the whole process of experiment and simulation before obtaining the final result, and the figure shown part of the project. First is the water valve, controller board, and lastly the fertilizer valve. And secondly, we proceed to development process. This is program coding is used for the whole process of the smart irrigation system. Arduino IDE software is used to transfer the code to ESP8266 microcontroller. Once the code is uploaded, the system will run automatically according to the desired process. And the figure shown the program coding already made for this project. And then we proceed to the coding testing. Before performing the actual simulation, Tinkercad software is used to simulate the coding that has been programmed. This method is a safe way before performing actual simulation to avoid major damage on the component. And for this topic also covered hardware testing, which is at this stage the experiment is performed using the actual material. When the soil is dry, it sends signal to controller or open the valve. When the soil is wet, it also sends the signal to the controller to shut off the valve. Next, for the software testing. Software testing also part of the process before we finalize the project. The process of this project is able to be monitored through the Blink apps using the smartphone. It has shown the value of the moisture, humidity and the temperature of the soil. It also able to send the notification to the valve status either open or close. Project implementation. The prototype of the complete design project is as shown. The water inject is flowing through the crop. It is controlled by the solenoid valve, which is receiving the signal from the ESP8266 controller when the sensor detect a low moisture level. The process is vice versa when the sensor detect is high moisture level. And then for the conclusion, smart irrigation system can enhance irrigation efficiency, especially with the introduction of wireless communication system, monitoring device, and enhanced control technique of the efficient irrigation scheduling. Finally, for this project has successfully functioned as expected, and the objectives of the project is completely achieved. And then lastly, for the recommendation, the prototype of this project is successfully implemented for a small launch irrigation tool. To commercialize this project, some components may require to upgrade based on the application and type of crop. For example, choosing the right sensor, considering power consumption, good internet coverage for the monitoring, and perform regular maintenance of the system to ensure it provides satisfactory result. Thank you.